Welcome everyone. Now let's talk about the primitive typecastings, which is the last topic of this module. So there are two types of typecastings in Java. One is known as the primitive typecasting and the other one is the reference typecasting. For now we are going to learn what is primitive typecastings because we already learned the primitive data types. And later on, when we learn more and more reference types, then we will learn how to do reference typecastings. So the definition of casting means converting from one type to another. And the definition of primitive typecasting is, it is the process of converting from one primitive type to the another primitive type. Okay? And this primitive typecastings, it happens between the primitive type of the primitive data types. Where the reference typecastings, it would happen between the non-primitive data types. Okay? And this primitive typecasting itself, and this primitive typecastings are divided into two categories. One is implicit casting, the other one is explicit casting. Okay? Implicit casting is also known as the widening primitive convergence, and the explicit casting is also known as the explicit casting is known as narrowing primitive convergence. Okay, so let's start with the implicit casting first. This implicit casting, it is the process of casting smaller primitive type to the larger primitive types. Okay, and the primitive typecasting, usually you apply it to the numerical primitive types, such as byte, short, int, long, float, and double. And of course, char, it also has a number. Every single character has a unique number, and the number will be taken as an integer as well. So that if you have a char, you could also cast it to other primitive types, starting from int to long, or to float, or to double implicitly. Okay? And this is known as implicit casting because this conversion is done automatically. Whenever you have a smaller primitive type, it can be automatically casted to the larger primitive type. Which means if you have a byte, short, int, those primitive types, you could directly assign them to the larger primitive types. Such as if I have byte primitive, I could directly assign it to the short primitive type. And if I have short, I could directly assign it to the int or to the long or to the float or to the double. Okay? Because the casting will be done automatically. That's why you will be able to assign the smaller type to the larger types. Now let's take a look at this practice task of this implicit casting. In this task, we need to declare a variable named num1 with the byte data type and initialize 25 to it. And then we will declare the variable num2 with the data type of int and assign the num1 to the num2. Which means you are trying to assign the byte to the int type. Okay? Byte is the smaller type, you are assigning it to the larger type. Since this one is known as the implicit casting, so you will not be required to do any casting operator by yourself. Okay? And then we need to declare a variable num3 with the data type of double and declare the variable num4 with the data type of int. Okay? And initialize it with 10. And then we need to assign the num4 to the variable num3. At the end, we need to print the num2 and num3, those variables. So let's take a look at this example together. Please create a new class under this package module 11, name it as implicit casting. Okay, let's work on this task together. Let me create my main method. And first I need to declare this variable num1 with the byte data type and initialize 25 to this variable. Okay. And here's my second variable num2. For the second variable, I need to assign this first variable. But first variable's data type was byte. Let's see if byte can be directly assigned to the int by using this assignment operator. You see, I assigned that, it did not give me any errors, right? And if I print this variable num2, let me use this shortcut to print the variable num2. You see, num2 right now is 25. So here's what happened. In Java, this is known as the casting operator. Okay, you will give the casting operator before this, before that value that you want to cast it to, before that value that you want to cast, and this value I want to cast it to the int type, right? So here in this parenthesis, I will specify this int. So this is known as the casting operator. Okay, we just casted this one to the int, and as you can see right now, IntelliJ is giving this casting in gray color. That's because this casting is implicitly done. There is no need for us to give it by ourselves. Okay, so you could just directly assign the smaller primitive type to the larger primitive type at any time, because this implicit casting, it is done implicitly. This is implicit casting. Okay, and let me also print out this variable num1. Let's see what's the value of this variable num1 is. So if num1 is implicitly casted to the int after us being assigned to this variable, does that mean that the value of this variable has changed? See, for num1 it is still 25, right? Because the only time that the value of the variable will change is when you reassign that variable. Okay. And then in the task, the next requirement is we need to declare double variable named num3. At the beginning, it's not initialized yet. And then next, we need to declare the variable num4 and initialize 10 to it. Okay. So num3 hasn't been initialized yet. Now let me initialize this num3 with num4. I use this assignment operator to assign this num4 to the variable num3. Now, as you can see, this is an int, right? This is an int. So can I assign the int directly to the double? If you look at our presentation slide, you see this is the range in terms of range of values. Double is larger than int, right? This is the primitives from smallest to the largest one in terms of range of values. So which means if you have an int value, you could directly assign it to the double. So here, this int is directly assigned to double because it is implicitly casted to the double type. If it is implicitly casted to double, this 10 is casted to double means it becomes 10.0. So which means 10.0 is stored into the variable num3. So if I print this variable num3, I should be getting 10.0 because num3 is double. Even if you store integer value, it is still casted to the double at the end. Okay. How about the num4? Just because it was casted here, does that mean that the value of this variable num4 has changed? Since you haven't reassigned it yet, if you did not reassign this variable, then the value stays the same, which is 10. Okay. So this is known as the implicit casting. So every time when you have a smaller primitive type, you could directly assign it to the larger primitive type. So make sure that you do now the order of those primitives from smallest to the largest. Okay. And the other type of primitive type casting is known as explicit casting. This casting is not implicitly done like the implicit casting. Okay. This casting, it is known as casting the larger primitive type to the smaller primitive types, which is the opposite of the implicit casting. Okay. And when you use this explicit casting, yes, there is a risk of losing data, because as you know, double is larger than float, float is larger than long, long is larger than int is larger than short, and short is larger than byte, right? So if I have, for example, 1000 as my int value, and if I assign it to the byte using the explicit casting, does that mean that the byte variable will be 1000? No, because the largest value that the byte can have is 127. So there will be some data will be lost, and you will end up getting some different numbers than what you assign it if it's exceeding the range of values. So when you are using the explicit casting, yes, you should also pay some attention to the range of values of those data types that you are casting it to. Okay, and this casting, it must be done explicitly. You need to use you need to give the casting operator by yourself. Okay, it will not be given by the compiler implicitly. You have to give it by yourself. And now let's also do a practice for the explicit casting. Please create a new class under this package. Name it explicit casting. I will give you an example of explicit casting here. So explicit casting is casting the larger type to the smaller type. Okay. For example, here suppose that I have this double variable num1, which is set to 100.5. Okay. And I need to make sure that this double variable is stored into this new variable num2. Okay. So I could use this assignment operator to assign this num1 to the num2. As soon as I do that, you see I am getting this compile error. If you move the mouse over, IntelliJ is telling you that the required type was short, but we provided double. Earlier in the implicit casting, when I assign this byte to the int was requiring int value, but I assigned it byte. It did not give me that error. That's because it was implicitly casted to the int type, right? However, when you have a larger type, it cannot be implicitly casted to the smaller type. Okay, so you will have to cast it by yourself. So here I would have to cast this one to the type that is competitive with this one, right? With the short right here. Okay, so if I try to cast it to int, for example, int is still larger than short, you cannot directly assign it. So I could cast it to the short. If I cast it to short, you see, now I'm able to store it, right? And just because I casted this one to the short and I assigned this num1 to the variable num2, does that mean the value of this num2 is also 100.5? So let's print this num1 and num2. Let's see what we will get. Here's our num1 and here is the variable num2. So num1, it still gave me 100.5 because this variable we haven't reassigned it yet, right? That's why it is still giving the old value, which is 100.5. Which is why it is still printing 100.5. And as for this variable num2, you see I ended up getting 100. But I clearly stored this data into the short. Why am I getting 100 instead of 100.5? What if I had a couple more extra decimals here? See, I lost all those data right now, right? So when you use the explicit casting, there's a risk of losing the data. And this short, it is designed for integer values, not for floating point values. Okay, so that's why it's only taking the int value, which is 100. And that's the value of num2. And let me also give you example of the another example of data loss, the risk of data loss. Okay, suppose that here I have this variable num3 which is set to 500, and I need to assign this variable to another variable which is, let's say, byte num4. Okay, and so this the variable's data type is byte. What's the range of the byte? What's the maximum value that the byte can have? The maximum value that the byte can have is 127. So if I assign this variable num3, first of all, int is larger than the byte. That's why it's giving me this compile error. Okay. So in order to store this into the byte, let me cast this larger type to the smaller type. So since the explicit casting is a must, in order to assign the larger type to the smaller type, you need to give it explicitly by yourself. Every time whenever there's operation is a must, or whenever it's required, IntelliJ also gives you the shortcut for that operation. Okay, so for this casting operation, for example, when I move the mouse over, you see I do have this suggest a solution button, right? I click it, and first option that it's giving me is cast the expression to the byte. So it's telling me to cast this int to the byte type. So I just cast this int to the byte type. Does that mean the value of this variable num4 right now is 500? Let's print the num3 and num4 one by one. Here's our num3, which is equal to 500. And I need to assign the value of this num3 into the variable num4. And now you see I assigned the value of this num3 to the variable num4. Does that mean that the value of this num4 is also 500? Let's run it. See, I ended up getting negative 12. That is known as the risk of data loss. Because the maximum value of byte could have was 127. Okay, so after the bytecode calculation, that's the number that we will have left. We have left. That's why I ended up getting negative 12. So yes, whenever you use this explicit casting, there is a risk of losing data. So you have to pay attention to the maximum value of the data type that you are casting it to. And here are the few key takeaways from this module. So the syntax of multiplication and module operators in Java are different from algebra. Make sure that you do now those arithmetic operators that we talked about earlier. And whenever you have multiple arithmetic operators that are given in the same expression, you have to pay attention to the precedence of those operators. Okay. And make sure that you know the order of the execution of those operators. If they are having the same level of precedence, it is always left to right. And yes, whenever you are using the explicit casting, you need to pay attention to the data loss in the explicit casting. Thank you so much, everyone. See you all in the next video.